Kinetics, Lessons 9 and 10, Reaction Mechanisms. If we look at this reaction on the page, this reaction involves 23 reacting particles. The chance of this reaction taking place in one step is very small. Most reactions take place in a series of simple steps, with each step depending on the others before it. In this lesson, we're going to take a look at reaction mechanisms. A reaction mechanism is the series or sequence of steps by which a reaction takes place. We cannot determine the reaction mechanism by just looking at the overall reaction. Mechanisms are deduced through much study and research, and you will not be asked to come up with a reaction mechanism. You will be given reaction mechanisms to work with. For our first example, the overall reaction is 4HBr plus oxygen produces 2 molecules of water and 2 molecules of bromine. This simple reaction doesn't take place in one step. It takes place in a reaction mechanism which has 3 steps, which are outlined here. We're also told that the first step is slow, the second step is fast, and the third step is very fast. Let's look at a couple definitions. Elementary process is defined as each step in a reaction mechanism. In this reaction mechanism, there are 3 elementary processes: step 1, step 2, and step 3. So each step is classified as an elementary process. The number of steps gives us the number of elementary processes. The rate determining step. The slowest step in a reaction mechanism. The overall reaction cannot be faster than the rate determining step. The only way to speed up an overall reaction is to speed up the rate determining step. In the above mechanism, step 1 was classified as our slow step. Therefore, step 1 is the rate determining step for this reaction mechanism. Here's the same mechanism. What we are going to do is we're going to cancel molecules that are identical on both sides, and then we'll add up what's left. I'm going to cancel this in a very specific way with some arrows. I can see that HOOBr is produced in one step, and then it's used up in step 2. So I'm going to cross it off with an arrow going from right to left. And 2HOBr is also produced in step 2 and consumed in step 3. So I'm going to cross those off. Let's put together what we have left. We have, now adding these together, 4HBr plus O2 would give us 2H2O and 2Br2 as products. Now this is my overall reaction. And this is the same overall reaction that we had earlier in our notes. Since I've crossed off some molecules here, we call these molecules reaction intermediates. They are produced in the mechanism and then used up later on in a future step. They are not part of the overall chemical reaction. Therefore, they're called intermediates. So HOOBr is one intermediate, and HOBr, we don't need to put the 2 there, but HOBr is the second intermediate. This reaction mechanism has 2 intermediates present. A reaction intermediate is a species, could be an atom, an ion, or an atom, a molecule, or ion, which is produced in one step and used up in a later step. An intermediate must appear on the right and lower on the left. So when I cross off an intermediate, I'm crossing off an intermediate going from right to left, and that's how I showed my arrow here. I'm crossing my intermediate with an arrow going from right to left, and that's how I know it's an intermediate. A catalyst. A catalyst is a species, atoms, molecule, or ion, which is consumed in one step and produced in a later step. In a reaction mechanism, we haven't seen one yet, but a catalyst must appear on the left and also lower on the right. A catalyst would appear in the opposite orientation compared to a reaction intermediate, and we'll see one of those shortly. Let's look at the following reaction mechanism comprised of 3 elementary processes, and we're asked to determine the overall reaction. The first thing that I'm going to do is I'm going to look for reaction intermediates. Reaction intermediates, remember, always go from right to left. So one reaction intermediate here is AX2, and I'm going to write it in as we go. AX2. I have another intermediate here of AX, and I have there's no other intermediates, but I can see that I have a catalyst. Now the catalyst is going from left to right. It goes in the opposite direction. Nothing else is available to be crossed off, so I can put together my overall reaction. Now let's put together what we have left here. It sometimes can be helpful to circle these in here so we don't lose track of what we have crossed off. And we've got 2A plus 2X to produce A2 and X2, and there is my overall chemical reaction, identifying intermediates and the catalysts that are present. Let's look at the next example. Again, we're going to do the same thing. We're going to determine the overall reaction by crossing off and eliminating intermediates and catalysts. And sometimes we have them and sometimes we don't. Let's first look for any intermediates. And I see that I have copper 2+. Now this, we're going to be careful. 2 copper 2+ on the right crosses off with the copper 2+, or sorry, copper +1 and copper +1 in steps 2 and 3. So there's an intermediate which is going to be identified as copper plus. I also see I have another intermediate of CuSO4. No other intermediates, but I can see here that I have a catalyst, copper 2+, and we've got 2I-. This is kind of buried in here, S2O8, I2, SO4, and SO4. So we've got 2I-, S2O8, 2-, I2, and 2SO4, 2-, and there is my overall chemical reaction. Example 3. We have a 3-step mechanism. However, this time we're missing step number 3. And we're given the overall. We can use trial and error to solve this question. However, I'm going to show you my way of solving this. To solve this question, we're going to take the overall reaction. I'm going to rewrite it as it is. And I'll take the given steps, but I'm going to modify them slightly. I'm going to take step 1, and I'm going to flip the reactants and products. So I'm going to call this step 1 star. And we will get C3 plus, A3 plus, A4 plus, and C2 plus. And I'm also going to do the same with step number 2. We get C4 plus, A3 plus, A4 plus, and C3 plus. I am now going to cross off. Now we got to be careful here. These are not intermediates or catalysts. We're just crossing off things that are on opposite sides of the equation. So 2A4 plus and A4 plus and A4 plus on opposite sides, those cancel. 2A3 plus with the 2A3 plus on the left will cancel. C3 plus and C3 plus will cancel. And this is what we're left with here. So we've got C4 plus, B plus, B3 plus, and C2 plus. So my step 3, now this is the right way. Step number 3 is B plus add C4 plus will produce B3 plus and C2 plus. So there is my missing step 3. So determine step 3, we've got it. We can take this and plug it back in and make sure we get our overall. So you could do a quick check if you would like to. And then if we're not asked in this question, but you could go back, plug it in, and then determine any intermediates or catalysts that may be present. But we can't do that with the flipped steps that we have here. It doesn't make sense to come up with intermediates or catalysts because we've modified the step 1 and step 2. Again, we have a 3-step mechanism. We have step 1 and step 3. We are to identify step 2, and we'll use a similar technique to go ahead and do so. We are going to write the overall as it is, not flipping it. So we have Cl2, CHCl3, HCl, CCl4. We're going to take step 1. We're going to flip it to give me Cl plus Cl to Cl2. And nope, step 3 is given. Step 2 is the missing step. We'll have CCl4. I'm going to line up my arrows here to make it easier. Cl and CCl3. Let's cross out what we can. Cl2 and Cl2. And we've got Cl and Cl. CCl4, CCl4. And looks like that's all. So let's identify what's left over. And this would form step 2, which will be Cl plus CHCl3 to produce HCl and CCl3. So there is our missing step 2. Again, we're not asked in this question here, but we could go back and plug in the missing step 2 and then solve for intermediates and catalysts, if any are present, from this step 2 back into the above mechanism. If we were to look at a PE diagram for a reaction mechanism, going back to the 3-step mechanism that we started off our notes with, here's our 3-step mechanism. in this mechanism here, we've got our reactants, which are here. And we can identify 3 activated complexes. The speed of each step was given to us. We're told that this is our slow step. Step number 2 is fast. Step number 3 was very fast, and this is from right at the beginning of our notes. The reason why step number 2 was our slow step is that the activation energy for step number 1 was our slow step, is the EA1. The activation energy for step 1 is the greatest of all of the steps. So if we supply enough energy to overcome step number 1, we have enough energy for steps 2 and 3. Each peak is a step or an elementary process. The higher the peak, or greater activation energy, the slower the step. The highest peak from the reactants, and this is key here, the highest peak from the reactants level is the rate determining step, and for us it's going to be step 1. The activation energy for the forward overall reaction is the vertical distance from the reactants to the top of the highest peak, and this is our rate determining step. So since we have 3 steps in this mechanism, we have 3 potential energy diagrams side by side by side. The assignment for this lesson is Hebden pages 28 to 30, numbers 46 to 55.